hear me?
Might want to, if you can speak up just a little bit, you're kind of quiet.
Can you hear me now?
Yes, much better. Thank you.
Okay. Hi, everyone. My name is Hung. Today, I'm gonna present my group, including Adam and Marcus, to present our projects on extreme events and anomaly detections. Firstly, I'll give you the motivation in the background for this project. So for this project, we choose Northwest Atlantic as a prototype because this region have been proven to be climate sensitive because of its locations near multiple circulations, and recent analysis on the Gulf Stream circulations have proved that the Gulf Stream is moving toward north. So we are inspired to monitor the temperature and the extreme heat wave in the region. And on the right figure, you can see the Gulf Stream and the Labrador currents at the circulation that control the temperature in the region. To work on this, we firstly build a data request from multiple sources, but we chose to use NOAA daily sea surface temperature. And then we identify the threshold and climatology within the 1981 to 2011. And then from that threshold, we identify the extreme events based on the definition from Hobday, saying that the extreme event will be defined if it lasts 5 or more days and it's warmer than 90 percentile of the baseline. And here's the results. So here's the results from my implementations for the marine heatwave package from Python. You can see here, show as the annual average likelihood of a heatwave event. So here is running like the 1990s, still running, you can still see normal, but the lighter the color is, the more likelihood the heatwave event happens. And as you see, there's one part that I want to draw attention is the 2012, which is later than the climatology period, where we can see here the heat wave happens all across the Northwest Atlantic. And to me, it sounds very dramatic. So for this implementation, it sort of implied that either the sea surface warming and accelerating all across the Northwest Atlantic, or the climatology and threshold from our package is not accounted for the accelerated warming trend in the region. So yeah, that's the results from the marine heatwave package implementations. And from Adam, he's also implements X-ray package. And yeah, go ahead.
Yeah, the difference in implementation between the marine heatwave and the X-ray implementation is the marine heatwave package expects either a pandas data frame. So it's an iterative process going through each location manually versus approaching it as a gridded data set and kind of allocating arrays for both the threshold to mask out when events are beyond it and looking at it that way. So in this image, you see that any location that wasn't above the threshold has been masked by that data set. But the results are pretty consistent. Kind of the pros of doing it the X-ray way is that if you know the workflow, you're mapping it out consistently as one single process to do across the spatial extent. But if you are planning to do it over a large area and don't allocate chunks of memory well, it can become very slow.
So for our discussions, we want to point out some uncertainty in our analysis. So firstly, the time period that we chose to estimate the climatology is based on a half-day rule of thumb of like 30 years, but we are sort of uncertain whether this can be always the case. And two, in the marine heat wave package, so far we cannot find any statistical metrics to determine how certain the climatology and the threshold from that. So I suggest that we can use an existing framework from CO2 Bayesian model where they sort of use parameters, convergence, or autocorrelations of parameters. And the final uncertainty is sea surface temperature might not fully reflect the circulation change, which can be shown if we have deeper data set from, for example, in situ measurements or Earth science model, Earth system model. And
in the initial project pitch, there was an interest in looking at falling events spatially. Using either of these approaches, you'll have the ability to label when marine extreme events occur. There's some research done by a researcher out of University of Washington, I think, that has a Python package called OceanHackWeek that can look at that pre-processed gridded data sets and label events based on kind of a threshold size to group them as larger patches and label them through time that way. So if anyone has interest, I would check out that repo.
okay, and that's the end of our presentation. Thank you for your listening.
Thank you. Thank you. All right.